we move further, it is very important for us to study some pneumatic walls, the details how it is working, because this will be very important for understanding how all various operations are done and how the configurations are done. So we can use the software when we know the basics. Okay, so this is very important. Let's pay attention. So pneumatic walls. First of all, definition. Walls are defined as devices to control or regulate the commencement, termination, and direction, and also the pressure or rate of flow of fluid under pressure, which is delivered by a compressor or a vacuum pump or is stored in a vessel. This is standard definition of a valve. So basically what it does, it is nothing but to control or regulate. It will control or regulate what? Commencement of movement or motion, termination of motion, as well as direction of movement, and also, sorry, pressure or rate of flow of fluid under pressure. So this is the definition. What are the functions? Valve perform three main functions in pneumatic installations. Number one, they control supply of air to power units, example cylinder. They provide signal which govern the sequence of operation. They act as interlock and safety devices. So these are basic functions of valves. So there are four basic classification of valves. So this will be common in both hydraulic as well as pneumatic. So this knowledge, these basics will be going to help you in both pneumatic as well as hydraulic circuits. So classifications are: number one, direction control valve, which controls the direction. Second, non-return valve. Non-return means which prevents the flow in one direction only. Non-return. Likewise, your tires of vehicles that are fitted with this non-return valve, wherein the air can't come out but air can go in. Means it prevents the flow of air in one direction only. The simplest example. Flow control valves, whatever taps you are using to control the flow, that is nothing but the flow control valves. Pressure control valve, wherein we control the pressure inside the line. So these are the classification. Now we spoke about ISO designation and why the ports are labeled and how it is labeled. What are the standard conventions? So here are the basic idea of ISO designation. So pneumatic symbol have been standardized in ISO 1219-12006, fluid power system and components. So these are standardized according to ISO. So worldwide it is used. Wherever the ISO are followed, we are using the same configuration so that our system can be standardized. Second, standard ISO 1219-1995 established the rule of drawing diagram of fluid power system using symbols. From ISO 1219-1, port designation are described in ISO 5599. So some examples are given here. So first column you can see the port. Second you can see old letters, means what they used to label it before this ISO 2006, and post 2006 what are various conventions that is followed worldwide. Okay, so we will go one by one. Pressure port, as told, pressure port is previously it is known by P. Also in hydraulics sometimes you can, if the system is old, you can see the P is written over there. So P stands for pressure port. Now P stands for pressure, but new system, that is a number system. Previously we used to follow the letter system, but now it has been changed to number system. That's why remember this one. This is the latest. So as told, one is always pressure port, one is always pressure port, that is supply pressure, supply port. Working ports. Now what is working port? Working port means the port which is connected to your cylinders, that is actuators. So working port are 2 and 4 and 2. 2 in case of 3 by 2 direction control wall, 4 2 in case of 4 by 2 or 5 by 2 direction control wall. Exhaust port. Now these are return port or exhaust port. Now how it is labeled? Previously it is labeled as R. Now it is labeled as 3, 5 and 3. So 1 pressure, 2 and 4 working, 3 and 5 exhaust. Exhaust means it should be connected to atmosphere. Pilot ports Y or Z. So in number system it is 1 2 and 1 4. 1 2 means you can see here 1 will always stand for pressure port, 2 is always stand for working port. Always connection will be from pressure port to working port or from working port to exhaust port. Okay, this is how the connection will be always. Means pressure P, pressure 1 will always be connected to either 4 or 2. This is the work of direction control wall, to connect pressure at 1 to 2 or 4 and to connect 2 or 4 to exhaust port 5 or 3. Okay, this is the working. So pilot means what? Pilot means a signal which is there which will create this connection. So if I label it as 1 2, that means it is saying that the pressure port 1 will be connected to working port 2. Okay, and if I write 1 4, that means it is stating that pressure port 1 is connected to pressure port 4. That means it is changing position. Pilot port are used for changing position of direction control wall, that we will see how the working and all the things. Pilot port Y or Z is 1 0, that means pilot port no flow. So 1 is connected to 0 means there is no flow, there is only pressure flow. So we can say that this position is nothing but a null position. Internal pilot port 8191, auxiliary pilot port. So these are not used. We use only pressure port, working port, exhaust port, and pilot ports. Next. So let's first talk about direction control wall. The function of direction control wall is to control the direction of flow in a pneumatic circuit. Direction control walls are used to start, stop, and regulate the direction of air flow and to help in the distribution of air in a required life. So two major functions. One is to control the direction of flow. Second is to start, stop, regulate the direction of airflow and to help in the distribution of air in the required life. So these already we have discussed in details, that what is the designation of direction control wall. So standard you can practice. I hope you have done. Now, what are the types of direction control wall? You can see here there are different types of direction control wall based on the construction, that is poppet wall or seat wall, wall seat wall, disc seat wall, diaphragm walls. These are nothing but the poppet seat walls. Sliding spool. Spool means what? There will be a certain part like this. This is the actual cross section over here. So this is a spool. This you can see this geometry. This is a spool, and due to this pilot line, this spool will be moved. If pressurized air come from this end, the spool will move towards right, and when the pressure is coming from this side, the spool will move left. So this will be controlled. This will be controlled by some pilot signals, and it will move. This is spool type. Okay, so here in the diagram some animations are there so that you can understand the working. See, this is nothing but our normal globe wall. This is called as globe wall, wherein there is a ball, so it is opening and closing. So this is nothing but what we are using in our normal pipelines, opening and just closing. There are no intermediate state. Here, here you can see here A stands for and B stands for working port. This is pressure port. This is tank. So this is hydraulic wall which is shown here. These are the push buttons. See, from this side if it is pushed, this is connected. P is connected to B. In second position, P is connected to A. So that is our requirement. That once P is connected to B, and other instance P is connected to A. So that our direction can be reversed and correspondingly the action will be changed. Let's move in details. So this is ball seat wall. Ball seat wall means there will be a ball seated on a wall seat. That means when you push this button, this is push button operated. When you push this button, what will happen? This ball which is held there with the spring force will be pushed down, and it is about to leave its seat position, and a cavity will be created. Now because of this push button, what happened, that this port P that is connected to port B, and here you can see in the initial position when there is no force or no push button is operated, you can see here the P port is not connected to A. P port is not connected to A. Actually, here only one port is there, so it may be A or it may be B. So actually this is only one port. So we can say that how many ports are there? Two ports. So two ports are there and two positions are there. So this wall is nothing but 2 by 2 direction control wall. Okay. So now the ball by the spring force kept at on seat so that P is not connected to A. So this position is there, default position, where one that is P is not connected to A, nothing is connected. Okay. Now when I push this button, what will happen? This push button, what will happen? This position will come here. This position will come here. That means actually physically what is happening? If you drop the push button, this ball will come down, pushing the spring force, and there will be a channel which will connect your pressure port with pressure port working port. So pressure port is connected to working port. Now we can say that in this position one is connected to 2. In this position one is connected to 2. So this is how the working is there. So physically this is happening, but by symbolic representation we are making it like this, because it is not easy to always draw these many big diagrams in our circuit. So this is how you have to understand that behind this operation there are mechanical elements, there are mechanical construction. So this itself is a very big market wherein the walls are designed and manufactured. So these are nothing but the ball seat wall or poppet. This is disc seat wall. Here from the diagram you can say that this is one port, this is another, and this is third. So there are three ports and two positions. So now in this default position, in default position 2 is connected to 3 and 1 is not connected. So 1 is always pressure port, so 1 is not connected, but 2 is connected to 3. That is, it is working port 2 is connected to what is 3? Return port, or you can say exhaust port. Now you can see, you can verify this. In default position 2 is connected to 3. The 2 is directly connected to 3. 1 is not connected because you can see here this is disk type. So this disk is fixed by this spring force on this seat, wall seat. So this is wall disc, this is disc return spring, this stem return spring, and this is moving wall stem, this actuator. It is called a stem. Whatever wall rod is there which is actuating the wall, that is called a stem. So here what will happen, when you push down this spring will be compressed, this spring will be compressed, then you can see here this part, this complete part comes down and it will block this third port. It will block this third port, means this position will be activated when this push button is pressed. So this is 1, this is 3, and this is 2. So this comes down, locking completely the port number 3. So nothing will be going from 2 to 3. Now what is happening? In completely actuated position, this seat will come down. Okay, seat will come down. So these 2 points will be touching this seat disc, and it will be pushing it down, and both are compressed by the spring forces on both the sides. So there will be a tight seal in between these 2 points. So now imagine that you push the button, now this comes down, so this one port will be now connected to 2. This one port is now connected to 2, like this. So you can see here, I can see that if I highlight from this one port, it goes like this. Okay, and this 3 port is not connected. So likewise the second position will be actuated when this point is pushed down. So this push button, so this point comes here, 1 is connected to 2, here 1 is connected to 2, 3 is not connected to anything, so 3 is cut off. So this is how the walls works. Advantage, some of the advantage: response of the puppet wall is very fast, short stroke to provide maximum flow opening. They give larger opening of walls for a small stroke. The wall seats are usually simple elastic seals, so wear is minimum. They are insensitive to dust and dirt, and they are robust. Seats are self-cleaning. Maintenance is easy. They are inexpensive. They give longer service life, short stroke, and few wearing parts. Give minimum wear and maximum life capability. So these are some of the advantages. What are the disadvantages? The actuating force is relatively high, as it is necessary to overcome the force of the build in respect to in respect spring and the air pressure. They are noisy in flow fluctuation is large. So these are some of the disadvantages. Now, diaphragm wall. These are another type of direction control wall. So diaphragm wall is nothing but, you can see in the picture here in the animation. See, when it is pushed down the diaphragm, this thing is diaphragm. This black. Yes, this thing is diaphragm. It is pushing it down. So definitely this part over here, this is nothing but what? This is stem. This is stem. So this is diaphragm. So when it is pushed down, the diaphragm comes down and this path is sealed. So there is no flow. When it is released, again the flow starts. So this is nothing but a simple uh, demonstration of diaphragm wall. So most important now, the last, that is spool direction control wall. Now what is this spool direction control? As shown in the first diagram, there is a spool inside the wall and which is moving according to the actuation. Okay. Now you can see here there is some demonstration is given here. When this push button is pressed, what is happening, which point is connected, and how the piston is moving. Now this is what a pneumatic circuit is. This is a control of single acting cylinder through a wall. So now you can identify which type of wall is this. Can you tell how many ports? First of all, see the ports. How many ports? One, two, and three. So this is three. How many position? One and two. One, two, one, two. So two positions. So this is 3 by 2 direction control wall. And which cylinder is this? Can you tell which cylinder is this? It is having only one port. Yes, this is single acting cylinder and it is spring return. So this is what we are studying this for. Now how this is operating this wall? See here. This is spool direction control wall, hand operated. That means this wall will not be automatically operated. This will be operated by push button, by hand operation. Okay. Now as shown in the diagram, we can say that this is 1, 2, and 3. In one position, 1 is not connected and 2 is connected to 3. So this is the default position wherein you can say spool is adjusted such that by the spring force such that 1 is cut off and 2 is connected to 3. 1 is cut off and 2 is connected to 3. So this is the first position. So we can say that this is initial position. Now if I push the button, if I push this button, what will happen? When I push the button, what will happen? The spring over here will be compressed and the spool uncovers the port 1. The spool, this spool 1 and this spool suppose 2. So this spool 1 will uncover the port 1 and now this 2 will cover port 3. So this is 1, this is 2, and this is 3. So now 1 is connected to 2, 1 is connected to 2, this here, see, 1 is now connected to 2, but 3 is cut off. Okay, this is how this, but when I release the force, what will happen? It again take back its own position because there is a spring force. So again the spool will come into one position. So see, unless the force is there, this spring is shown. So that means spring return. This is a spring return wall. That so the one push button and spring return. So one side actuation will be push button manually hand operated. Other side it is automatically by spring force. This is a hand operated spring return the spool direction control wall. Okay, so understood. So how the position is changing and how the ports gets connected means by seeing this symbol we are just saying that one is connected to two, but we have to understand that how this thing actually takes place physically in the physical walls. So now here you can see. So I think I have made it clear. Hope you understood. Let's move ahead. So this is one more type wherein you can see here pneumatically actuated. Previous one you can say it is hand operated, so there is a push button. If I say hand operated, there is a push button. If I say pneumatically activated, that means there is a some pneumatic pressure signal. Pneumatic pressure signal, that means there is a pressurized air signal coming which will change the position of spool. Means here from I have to supply some pressurized air, some high pressure air I have to supply, and from this high pressure air this spool will be pushed and the spring force over, overcoming the spring force and uncovering this port 1 and 1 is connected to 2 and 3 will be covered, so 3 will be disconnected. So same thing can be achieved by pneumatically, but this is done for automation purposes. That means when one part is over, that flow signals will be given to this and another sequence will be begin. Okay, so this is nothing but pilot operated. So pneumatically actuated valves have following advantage: great flexibility, adaptability for use in safety circuits, various controls, sequencing. These are basic advantages. Now pneumatically actuated. So same pilot operated, but this is 4 by 2 direction control valve. How it is connected? So see the symbol here. Symbol says that in default position 1 is connected to 2 and 4 is connected to 3. One is, so this is default position. So what it is says, 1 is connected to 2. So let's see, 1 is connected, 1 is connected to 2. Okay, connected to 2 and 4 is connected to 3. That means 4 is connected to 3. Now tell me, 1 is what? Pressure port. 3 is what? Exhaust port. Yes, so direction will be always 4 to 3. Okay, working port. 2 and 4 are working port. So they both can act in direction, but 3 will always be in exhaust, 1 is always be in inlet. 1 will always be in inlet. Okay, so now this is one position. If the position change, what happens? Next position. In next position, what it says, 1 is connected to 4 and 2 is connected to 3. Let's verify. In second position, the spool moves towards its right. Spool moves towards its right. See this gap here. Spool now moved towards its right. What happened? This spool over here is uncovered. Now this spool is also kept there by the spring force. Okay, so that is a very tight fit. So let's verify this. 1 is connected to 4. So 1 is connected to, from here it is connected to 4. Yes. So 1 is connected to 4. 2 is connected to 3. It is saying that 2 is connected to 3. Let's verify. Where is 2? Yes. Now working for 2 is connected to 3. Yes. So this is both are verified. So now you understood that how this directions are there. So 1 is always connect inlet, 3 is always exhaust. Okay, so 2 is connected to 3, that direction will be like this always. Understood? Okay, let's move further. Suspended disc type, this is also used but not much. This is the rotary walls. So you can see the diagram. This is what lever type rotary actuator, sorry, lever type rotary wall, wherein these are the different positions. So from this you can say that it is 4 by 3. Yes, 4 port, 3 position, 4 by 3 direction control wall. So how that ports are connected, you can see this diagram. Okay, don't go into details, but for a knowledge sake, just have a quick look and understand. Next. So these are the different positions, how it is set. Now this is very important, that the theory, now you understood that how these walls are working. Now we have to understand that what are the methods of actuation that are available, because depending on this we have to configure our wall in the software. Okay, so what are the types? Manually actuated, mechanically actuated, pneumatically actuated, electrically actuated, and combined actuation. So these are the various combinations or configurations under which our walls will operate. Manually actuated. What is this? Manually? Manually means by hand. Mechanically means by certain element. Pneumatically means pressurized air. Electrically means electrical signal. Combined means whether it is mechanically and electrical, pneumatic and electric. Depends. Okay, so let's go in detail. So in software you can see these symbols over there. So what are they? Manual. First we will see manual operations. Manual actuation. That means the wall, the wall, this wall will be, see here, this wall is operated pneumatically, this wall is operated by hand. This is manual operation. So you can see here there is a push button. So in this diagram, you can see that this is manual. So push button it is shown by like this symbol. This is push button. This is general. Okay, this is generic symbol. This is push button. This is detent lever. That is detent lever means there will be lever and it will be secured once actuated. That means if you release the push button, any push button operation means to bail. Okay, bail button you have seen, doorbell. We are just pushing it once and it is coming it back. It is not a detent lever or detent switch. Detent switch means which stays at that point after releasing the force. So, for example, we switch on the fans. It stays there unless we again switch it off. So that is detent kind of thing. But always push button will be you have to apply a continuous force for that particular motion unless it will be switched off. Okay. So doorbell is very good example for this, and you can say fan, lights, everything can be understood by detent lever. So once it is pushed, see the detent lever here, some mechanism will be there and it will be stopped at that point. Again, you have to apply the force and change the position. Foot pedal. Foot pedal is also one of the manual actuation technique, wherein foot pedals is provided, and by foot we have to apply the force and change the wall position. Okay, mechanically. Now understood. So among this, most popularly used is nothing but your push button and detent lever. Depends. Mechanical. Mechanical means what? It should be automatically actuated without any manual interaction or manual involvement. So mechanical is nothing but for use for automation parts. Okay. So now what are the various types? Spring return. That means automatic. It will automatically use take its position by spring. So this is one side spring. So you can say right actuation is by spring. Spring centered. That means both sides there is a spring force, so your spool will be at the center. Here from this side spring is there, so it will be at left part. Okay, spring force is there, so your spool will be at left position always. When the force is applied from this side, it will push the spool against the spring and it will move towards right. And again when this force is removed, then again it comes back to its original position. Whereas this is spring center. Spring center means when both sides spring force are there, it will always stay in center direction unless it is moved by force from any other. So this double spring will always be associated by any pilot signal. Okay. Now this is mechanical. Roller operated. This is most commonly used roller operated. So whatever the sensors we are talking, that is labels A0, A1 and B0, B1 in that circuit, that in that labels, cylinder labels, so that are nothing but the rollers in case of pneumatic circuits. Okay, so these are the rollers. This is idle roller, that means it can move like this. So these are the four types for mechanical. One is spring, other one is roller and idle roller. So basically mostly this roller type is used. Now pneumatic. Pneumatic you can see direct pneumatic. So this is nothing but a pilot signal. This is called as pilot. Pneumatic means pilot signal. So compressed air will come from this part and it will move the spool. Indirect pilot operated. Indirect pilot operated means it gives the signal and then the movement will be occurring. So this is direct and indirect. Mostly we use direct one. Electrical signal. Now these are also the actuation. This we will require in electro-pneumatic, not now. Okay, but let's see. Single solenoid, double solenoid. Solenoid means there is a electromagnet powered by certain electrical signal. So if it is given the electrical signal, it will generate the magnetic force and the spool will be pulled towards it. So this is left, so single solenoid, this is double solenoid. If this is activated, the spool will be shifted on left. If this is activated, spool will be shifted on right. And normally it will stay there unless the other spool will be activated. Okay, sorry, other solenoid will be activated. So mostly we will be using direct pilot, roller operated, and push button. These three are mostly used. Okay, so just remember these three. So non-written walls. Understand till now? Now, now here comes non-written wall. We talked about that all the tires where the compressed air is hold that are nothing but non-written walls. Reciprocating pumps, reciprocating compressor also have this non-written wall, which allows flow only in one direction. Okay, it doesn't allow the flow in reverse direction. So check wall, shuttle wall, restrictor check wall, quick check wall, and two pressure wall. So you can see here. This is the symbol for check wall. This is the symbol for check wall. That means you can see here. What is the direction of flow you can predict from this? Actually, it is, see, this is how the check wall is shown. Sorry, we'll try to draw. Yes. So this arrow means this is a seat, and on this seat the ball is fixed. Now, if the flow, now can you tell me the direction of this? In what direction or in which direction it will it will prevent the flow and it will allow the flow. So let's stop. When the force, when the pressurized air try to come from this side, what it will do? It will again push that ball against the wall seat, making the seal very firm. So no direction. So here no direction. Now if the air coming from other side, what will happen? This ball will be lifted. This ball will be lifted and the air will pass. So this direction is nothing but the direction of flow, and it will not allow flow in this direction. Okay, so only one direction. So this is non-written or one-way wall or check wall. Okay, so this ball generally are there by the spring force. See here, spring force. So it is hold to on the seat by using the spring force, and to lift it, the pressure applied should be equivalent to the force applied by the spring. Okay, so physical are there. So shuttle wall, functional diagram or restriction check wall, function diagram, quick exhaust wall, and two pressure walls. So these are the different types of check walls used in the industry. So let's stop. This is what we are working for, and we will make this circuit in the next lecture. Thank you.